VLPSos here. This is a video lesson for Python programming. Interval GUI. GUI standing for Graphic User Interface. And I'll talk about in a moment what we mean by interval GUI. This code file started as toggle movement. Let's take a look at what was accomplished when we coded for toggle movement. We have a simple screen. A green square was drawn as an instance of a class called object. And by pressing the keys, we can change the location of where that square is drawn. We have stepped movement implemented by pressing the arrow keys in 4 directions. We have toggle movement by pressing A, S, D, or W. And toggle means that when we press a key, it toggles it on, and we have to press a second time to turn it off or toggle it off. We can go in 2 directions on an oblique. If I press A and W, I get to the left and up at the same time. And then I have to press the keys again to turn that motion off. That's toggle movement. But what about interval GUI? What we want to do with this is not change the style of animation, but we want to change how we interact with the controls for that animation. We want to make some on-screen buttons. So this would be a simple graphic user interface. The user interfaces with the graphics by clicking on top of them to get the motion to turn on and off. If we drew 4 buttons, then we could use those on-screen buttons, very simple ones. These buttons would just be colored squares on the screen. But by clicking on the top button, as long as the mouse is inside the top button square when we click, then that's the same as pressing the key to toggle upward movement on. And then we'd need to click on the top square again to turn it off. So that would be toggle movement with a graphic user interface. Interval is the style that we would code for to detect the interaction of the mouse click with that on-screen button. Interval is referring to the intervals of where this button is drawn, or the graphic of the button is drawn, as a horizontal interval, a width, and then a vertical interval or a height. Intervals because we have a button location on an interval from one X position to another in order to determine the width of the button, and an interval of a Y location from one Y value to another in order to find the height of the button. If the click is within these intervals, the horizontal and the vertical interval at the same time, then the mouse click must be located on top of the button. That's how we detect interaction of the mouse and the graphic that represents the button. So let's code for that. We're going to change or add to our toggle movement program in order to code for that effect. Toggle movement started, we'll take a look at some of the features, with a class called object. That's for the on-screen square. It has an X position and a Y position, a step for the arrowed movements where it steps by 10 pixels at once. We have a size that is the width and height of the button or the square that's drawn. And the speed was used for how many pixels, in this case 0.1 pixels of location change per frame. And we multiplied that by timing, the variable that represents the number of milliseconds it takes to compose a frame. So our motion when we move continuously with toggled movement is proportional to how much time is going by in the real world. In our function before our frame loop, we have some booleans that help the algorithm to make that effect happen. We create an object, one instance of our class object, as the on-screen button. There's also some code that's been added to this file that's been commented out temporarily. That's what we're going to get to to add the interval GUI in a moment. Let's continue to take a look at how the toggle movement was accomplished. We have more code that's been commented out that we'll add back into this soon. We have the two algorithms for changing the y and x position variables of the square. We have this block that is implementing the stepped movements with the arrow keys. This block is for the toggled movement with the A, S, and W keys. This movement still works, as we've seen, but when we add the on-screen buttons, we're going to have a third interface. We're going to have the arrow keys working, we're going to have ASDW working, but we're also going to be able to click on the screen. And we have a pause effect that's been implemented. The event queue includes detecting key down and key up. Key down for take step, that's the arrow keys, and a key down to toggle the A, D, S, and W keys. And we'll make a note that the toggling was this strategy of having a Boolean variable be reassigned to be not the previous value. So we get the Boolean to turn from true to false and from false to true on the key press. We only have one key up event, and that's for the left shift to increase the speed. That's the previous code. Now let's talk about what it means to create a graphic user interface. The first thing that we're going to do is we're going to make the graphics of the buttons show up on the screen. We're going to be very simplistic. We're going to create 4 buttons, and we're going to locate them in what I'm calling a button bank. So they look like this in our 4 primary directions. Once we get them on the screen so the user can see them, then we'll code for interacting with those buttons. Now, to prepare for drawing the buttons, I have written already a button class. I'm going to uncomment this code. We're writing a class for a button because we're going to take the strategy that each button is an individual instance of the class button. The attributes of a button will be name, and we'll use the name also to refer to the effect of the button, left, right, up, and down. We have the location of the button, which is going to be a tuple of 2, where it's drawn the top left corner. We also have a size. Buttons can be different sizes, and color, and whether the button is active based on this Boolean attribute called active. The way we're going to use this Boolean attribute active is when we detect the user interacting with the button by clicking on top of it, then the attribute active will be assigned to be true. A button that is actively true will then cause the effect, the desired effect. So we have a strategy to create buttons, create them and then draw them to the screen as squares, interact with them with some math that will involve testing intervals, mathematical intervals of horizontal and vertical position. And if the interaction means that the user is clicking on it, then the active Boolean becomes true. Then we'll detect, or we'll take a look at all of the buttons to determine if any of them are active, and then respond to that type of button, whatever the button's name is, left, right, up, or down, to actually then finally affect the desired motion or animation on the screen. So now that we have our button class, let's make some. We have commented out a section of the code that's already been written. We have a button dictionary, or buttons dictionary, where we will create 4 instances of the button class and put them in this dictionary to manage. The argument for the init function to the class has been posted here as a comment, so when we make buttons, we remember that we need to give it a name, then a location, a size, and a color. Now, the location attribute is going to need to know what we want to do to organize the buttons in this way. So part of preparing where the location of the button is going to be, we need to declare some variables that will be the size of the buttons and the borders between these buttons so that we can get the locations of all of these buttons very precise so that when we draw them, they arrange themselves in this nice, reliable, well-organized pattern. So before we're ready to make buttons with the location attribute, there are some variables that have been already written, and we'll uncomment them and talk about how we're using these variables. Button border is going to be the amount of space in pixels between each button. They're not going to be cramped up next to each other. They're going to have some border amount around them. That's the variable button border. It's 10 pixels. Button size is going to be the height and the width of each button. So these buttons are going to be squares. Their width and height are going to be the same. The button bank location variable is a little sophisticated. It is the location of this point that's been highlighted. This is going to be a reference point, and all the button locations are going to be based on a place relative to this location. If the location of this point were to change, then all of the buttons would move and be oriented based on this location here. It'll be a little more clear as we start to find the specific button locations relative to this point. But we need to declare what this point is. And the way that we've done this is algorithmically. That button bank location is a tuple of 2. It's an x and a y coordinate. What we've done is we've taken the screen width and subtracted 3 button sizes and 3 button borders. In other words, the x location of this point took the screen width itself and subtracted 3 borders, because there is a border here, and a border here. Remember, border is the space between the buttons or the edge of the screen. And to get to this location, we needed to take the screen width and go back by 3 of those button border widths. We also subtracted 3 button sizes, because again, to get to this X location, we needed to subtract 3 button borders and 3 button widths, 1, 2, 3, to get there. What did we do vertically? We took the screen height and subtracted 2 button sizes and 2 button borders. So to get to this location, we start with the screen height and subtract 2 button borders, 1, 2, and 2 button heights, 1, 2, to get up to that location. That might be a little sophisticated to understand, but it's worth wrapping your mind around this explanation so that you're able to code for something like this yourself. What we've done is we've declared for a variable based on the dimensions of the screen a location here, which guarantees that no matter what the border or what the widths or what the screen size is, this button bank will automatically always fit in the bottom left corner of the screen, and it'll fit quite well. We could change all of these numbers, and this math right here will make it work dynamically. Very good way to code. Now that we have those important numbers set, we're going to create our buttons. Let's uncomment one of them and see what it meant to create a button. First of all, we have the name of the dictionary and then the key, which is a description of what that button is going to be used for. This is going to be an on-screen button to move left. The first attribute that we have to put into the argument for the init function, other than self of course, is left, which is also the name of the button. So the key and the name attribute are the same. Then we have the location. The location of the button is this tuple of 2, and it requires some of the same reasoning that we just went through to find this location. So the location of this left button, which in our button bank is going to be here, is going to first start with this location, and to the X position we're going to add nothing because location of the top left corner of this button is already aligned horizontally. Vertically, in order to get to this button location from this point, we need to add a button height or a button size and a border to get down to this top left corner of this button. So let's take a look. The location of the button has an X value which is the same as the button bank location, that dot. And the location of this button starts with the Y value of the button bank location, again this point, and we add a button size and a button border to get to that top left corner. So we are basing locations of the buttons with a little bit of math starting from this location. We also give it a size, which was already declared and used, and a color. The color and the size are going to remain the same for the other three buttons. The locations are going to be unique and their names are going to be unique. I'm going to uncomment the other three, down, right, and up. We can go through the similar reasoning for each one. Let's just do it for one to review how we're getting the button location, which means the top left corner of that specific button based on the button bank location, this point. Let's take a look at the button for going right. Its name and key is here, and its location is this tuple of 2. Let's take a look at the coordinates of that location to confirm our understanding in our math. This is the X value of the location of this point, the top left corner of the button that is going to be used to move right. We would expect that the X value is going to be based on this X value plus a button size, plus a border, plus another button size, plus another border to line up with the X value here. Is that what we got in the math? We started with the button bank location, the first value, which is X, and we added 2 sizes and 2 borders to go from here to here. Now vertically, we need to start with this Y value and add a button size and 1 button border to end up at this point. This here is the Y value that starts at the Y value of the button bank location and adds 1 button size and 1 button border. All of these locations are now relative to this point. Now that we have our buttons created, we can draw them. In our frame loop, we have an order of our code that makes sense for creating the movement, and then at the bottom, or some of the last things that we do in the frame loop, is draw to the screens the things that the user is going to see. And the very last thing we do in the frame loop is update so that the user can see the changes, and then process our event queue. So if we want to see those buttons, that's something that we're going to do under the comment compose screen. This is also something that has been written already, and I just need to uncomment it to add it to the code. We can see that we are iterating through the keys of our dictionary. Our dictionary is buttons. So for all of those buttons, we're drawing a rectangle. The rectangle is going to be drawn to the screen. It's using the color attribute of the button to determine the color. And it is referring to the X and Y location with the location attribute. And of course, the size of the rectangle is used twice because the width and height are the same. 0 means fill that in. A 0 line thickness will fill it in. Let's see what we got at this point. We can see that we have on-screen squares of blue. Those are our buttons, and they're all formatted to be in the bottom left corner of the screen, and they have uniform borders around each other and the edges of the screen. All of that focus on the math and the dynamic programming, let's experience by changing that a little bit and seeing how the math will make it work out. I'm going to increase the button size to 120, and I'm going to increase the border to 15. Now, if the math works out, it means that we should have larger buttons, more space in between, but it should still be well organized and in the bottom left corner of the screen. And our coding is paid off. We can get that math to be done for us very easily. We'll keep the button sizes very large. Let's now talk about interacting with the buttons. So if I pressed on those buttons right now or clicked on them, nothing would happen. We need to affect the motion of clicking on those buttons so that the user experiences the illusion of pressing on the on-screen buttons. Now, of course, it's an illusion because all we have to go on in the programming is the location of the buttons and their size and the location of the hotspot of the mouse. We just got to check when there's a click that the hotspot of the mouse is in a location relative to the location of the buttons and the size to determine with math if the click is happening on top of a button to the user's perspective. First thing that we're going to do is we're going to detect the click of the mouse. In other words, in the event queue, for the event type 5 or 1025, that's the type of a mouse button down, a mouse click down. And we'll tether this to the left click. We've added this Boolean. Left click is equal to true, which means when a click has happened and the specific button that was pressed was 1, then this Boolean of left click is going to be assigned true. This simply detects when this Boolean is true that a click has occurred. Now we have to determine if that click was on top of a button. This line of code that hasn't been coded is going to be where we're going to determine if the click was equal to true, and we can start our code block with that condition. If left click is true, then we want to know now with this code where that click occurred. The click occurred at the mouse location, but we need to know if the click occurred at the mouse location, which is current and came from the get position and is assigned, the mouse location is assigned to the variable mouse location if the mouse location was on top of the button. So we have our buttons, and we want to, when a click happens, when the Boolean of left click is equal to true, detect the location of the mouse if it is within any of these button locations. What does it mean to be on top of a button or in a button location? It means that the X and Y values of the mouse at the click was within any one of these intervals where the button is located and how large the button is. That's a little bit sophisticated. The first thing that we're going to do before we write those conditions is that we're going to immediately assign left click to be equal to false. So this is only done once per click, once per frame. We're going to determine if we've clicked on a button. Clicking on the button requires two conditions. If the horizontal location lines up, and if it does, we'll test if the vertical location lines up. So what do we mean by horizontal location lining up? Going back to our graphic before we code it, let's say we clicked within this button. What would be happening horizontally with the location of the mouse and the location and size of this button? It would mean that the X position of the mouse is going to be greater than the X position of this button. It's going to be greater than the left side of this button. But at the same time, the X location of the mouse is going to be less than the right side of this button. The right side of this button is the location of the button plus a button width. So let's turn that into a condition. If the mouse location, but only the X value, which is the first in the tuple of 2, 0, has got to be greater than or equal to the buttons, because we need to test all of them, not just one. X location, which is in the 0 position of the location attribute. This is one part of the condition. To review, we're comparing the mouse location to the button location. And we're going to need to do this for every button, so we could start the iteration for key in buttons. And this condition is already written to take advantage of the iterating variable key so that we'll be checking all of our buttons. Only one button can be interacted with once, but we don't know which one, if any, so we got to test them all. That means that this part of the condition has tested this. For every one of these buttons, if the mouse location is greater than the X location of the button itself, then we must be to the left of the right side of the button. And the mouse location with an index of 0, just the X part, must be less than or equal to the current button with the iterating variable key, location with just the X part, so we index 0, plus the size of the button, which is itself an attribute of the class. This second part of this condition is the part where it's now testing, again, once for every button, but we'll treat one as an example, that the X location of the mouse is also less than the right side of this button. And we get to the right side of the button by the X location plus a button size, which is its width. So if both parts of this condition is true, then it lines up horizontally. The mouse location is greater than the left side of the button and less than the right side of the button, lining up horizontally. But we could line up horizontally but have the mouse be above or below and not right on top of the button. So we need to also line up vertically. We can do that because this line is a very long one in a separate second condition. So we have, if all of that is true, then we'll set another condition to test this vertically. If the mouse location with an index of 1, so it's its Y value, is greater than or equal to buttons in the button dictionary with the current key value, location attribute with an index of 1, so we're accessing the Y location of the button, then it is below the top of the button, but it also has to be above the bottom of the button. So at the same time, or and, as a composite condition, the mouse location Y value of with an index of 1 has to be less than or equal to, in the buttons, the one with the current iterating variable key, location with an index of 1 for the Y value plus its size. In this case, size is being used as the height. If these two very long composite conditions are both true, then here is what we've tested. Yet again, because this is sophisticated, we want to think about or try thinking about it many times in order to get it right in the end and be able to code for this ourselves. We need to test every single button to see if the mouse button location is greater than the X position of the left side of the button, and at the same time less than the X position of the right side of the button. The Y position has to be greater than the Y position of the top of the button, and at the same time less than the Y position of the bottom of the button. Hopefully, with this math, no mistakes have been made. It's easy to do so. And we shall test it. But if we have both of those conditions to be true, then what are we going to do? It means that a click was made and the location is on top of this button, the one that has the current key value. What we want to do in this case is assign its active Boolean attribute the value true. It's active because we've just interacted with it. This requires testing, and we can test it if our active buttons are causing motion to occur. This code block here that has been written already will iterate through all of the buttons. It will determine by a condition if the active attribute is equal to true. If it is, it'll turn it immediately false so that we only get one effect per button clicked that turn the active Boolean true. And then it's going to check the name of the button because the name describes the motion that a click on it should cause. So if the name is left, then it will do this familiar toggle of a Boolean variable. Step left will be equal to not step left. So it'll toggle it on or it'll toggle it off. And the step left variables are the ones that in the change of position attribute we're looking to actually cause the X and Y position attributes of the object that we're moving to change. Let's see if all this works. Clean up some error. Hopefully they're simple. In this very long condition, a period was left out. We have the buttons drawn. A click on the top button for up toggles it on and off. If we click left, we can toggle left motion on and off. The bottom button seems to work, and the right. We can also turn bottom and right on and then toggle them off. We have a graphic user interface. If these conditions are difficult to understand, if it was difficult to follow the explanation of how they're written, let that be okay. This is a fairly sophisticated thing to write, and it usually takes hearing it and seeing it a few times and then struggling to work it out yourself in order to gain confidence. Now you've seen how to draw rectangles that the user can interact with by detecting if the mouse position lines up with the horizontal and vertical location intervals of the sides of the rectangle. In this case, the buttons. The buttons are rectangles and they're squares if their dimensions are equal. You have seen an example of a class being used to make a few buttons whose attributes are used to both draw them as a graphic and test for collision with the mouse position. Use the button class to make an additional button. Make it red. Position it so the use can see lined up below the down button. Program it so that when the user clicks on it, it pauses the action. In other words, add to the button bank. Make that button, new button, red, and have it toggle pausing on and off. Have fun.